Hello, everybody, and welcome. I hope you can hear us well. So we will be waiting 30 more seconds before starting, just so that most of the attendees that registered are in the meeting. All right, so I think we can start. Welcome everybody to this webinar. We're going to focus on a really specific topic related to innovation, pragmatic innovation using affordable AI. I also wanted to share with you a few things, upfront before starting it and deep diving it. So we're going to record this. And we are having right now, I think, attendees from US, Europe, and also some Australian attendees. I hope some of them, didn't get to sleep yet, but we're going to have the recording available for later use. Also, during the discussion, we're going to have the questions panel being open, so you can ask as many questions as possible. And at the end, towards the end, we're going to try to respond to all of your questions. And also at the beginning, we've sent a poll about your experience with AI. How many projects or initiatives do you have? And also, what's going to be next. So let's get to it then. So I've seen the results from the poll. They're very interesting. It seems that most of you don't have that many experience with AI/ML solutions, but you're planning to do it, which is a nice thing. About ourselves, before starting it, so I'm Bogdan. I'm a delivery manager working in Yonder for more than 11 years now. But under the shirt, I'm a very passionate technologist, and I'm here with my colleague Vlad. But I'll let him introduce himself for all of you.
Thanks, Bogdan. Yes, I'm Vlad. I've been with Yonder for the last year as a machine learning engineering lead. In the past 5 years, I've been involved in some data engineering, data science, analytics, and machine learning projects. And my background is mainly software engineering.
Cool. About today's discussion, so we will be going a bit through an introduction about AI, trying to understand, what it's all about. What are the challenges when implementing AI projects or AI initiatives, adoption possibilities, and what's in there for you as a business to business, as most of the attendees are part of ISVs. Some use cases, and we're going to try to provide a framework for reasoning about how to find them. And last but not least, a thing which is on the lip of every technology stakeholder, how late am I to the party? And well, just to deep dive, I'll try to switch the focus to a very interesting domain, which is spaceship programs. So if it is to do a parallel between spaceship programs and AI, they're very impressive, they're very exciting. On the other hand, when it comes to launch into production, as you've probably seen on many of the launches, there is a big boom at the beginning. So it's similar with AI. So around 60% of the models don't actually make it to production. And some bad voices are saying that the number is even higher. And I'm very curious, why is that happening? So Vlad, what's your feeling about it?
Yeah, it's a very interesting phenomenon indeed. But and I think Eric Siegel says it very bluntly and nicely in the sense that in one of the studies that you've also seen this number about models not being deployed to production, he concluded that in most cases, it's the only missing ingredient for this lack of deployment or lack of success is the right leadership practice, and also with some executive ramp up. So what does this mean? Of course, as for any emerging technology, there's a lot of hype, right, with AI. But the problem is that the enthusiasm generated by this hype is not channeled in the right direction. And as we can see in this photograph, basically, whenever we're channeling our attention to the means by which we reach a goal, i.e. in the case of machine learning, the model, very complex heuristics and stuff like that, then we can end up in failure. So basically, the teams and the organizations should focus more on the goal, so the delivery of the model to production, rather than the model itself, as we will demonstrate during our talk.
But Vlad, maybe before going that deep into philosophy and so on, and just from starting for a more practical point of view. So everybody, I've seen this tendency of interchanging those words. So AI, machine learning, deep learning. What is this all about, and why is that happening?
Yeah, when entering this field, I was also preoccupied by this question, and it's a very good one. So basically, when we're thinking about artificial intelligence, this is a sort of a branch of algorithms. So the generic concept of algorithms, which is a sequence of these instructions that given to a computer automates a certain thing. Then, once we think about artificial intelligence, we think about the fact that it's that branch of algorithms that kind of emulate human behavior in any way. Now, when we think about machine learning, it's actually a part of artificial intelligence. So I emphasize a part because artificial intelligence can mean much more. For example, it can mean search, it can mean planning and probabilistic reasoning. So when we think about machine learning, they're referring to the tasks where the models actually learn instructions actually when shown data without being explicitly programmed to do so. And then there's also this term of deep learning, which is widely used lately, and this refers to a special type of machine learning where artificial neural networks are used as internal structures that can adapt, they're adapt to learn right from when shown large amounts of data. So to conclude, AI is used just to ensure that that the entire domain is covered and is mainly used in business domains from what we've seen, whereas machine learning and deep learning is used mostly in technical contexts where the teams know exactly that they're going to use machine learning or deep learning.
Yeah, so maybe as a thing to be mentioned from the beginning is that we're going to interchange those words. So we're going to use a lot AI and ML. And if it is to think more about the practicality of the term, I think it requires to frame a bit the problem. So when talking about AI, we're talking on one hand about broad AI or AGI, and the other thing that's also part of AI, it's narrow AI. And if it is to go a bit deeper into the details, basically AGI or broad AI tries to replicate humans, like the conscience and so on and so forth. This is a very complex problem, usually is being tackled by companies like Google, Amazon, Microsoft, and it requires a lot of R&D research, and it's not there yet. While narrow AI refers to solving human-specific tasks using all sorts of algorithms on doing it. And if it is to classify it a bit, we're talking about, you know, things like computer vision, or things related to natural language processing, or audio signal processing, which, you know, if it is to put them into a category, this is basically machine learning applied in narrow AI. And our entire talk of today is actually focused on narrow AI. All right. Moving forward, as we understood, you know, what is this all about? Still, there are a lot of challenges from organizations on adopting it into their case. And I think during the years, we were very interested to understand why. Why is that? What are the challenges? Why is not yet adopted? And Gartner released a really nice questionnaire result and interpretation. And it seems that organizations in general don't understand and don't know how to tackle it. And of course, there are a few things related to this. So basically, they either don't have the skills or the proper staff, or, you know, the data scope or quality, or it's also about understanding the benefits and use cases. So we will be trying to bring clarity more through this presentation. Now, a common misconception when talking about AI is that in your added value software, while developing either features or programs that contain artificial intelligence or ML, everybody's thinking that the ML code is something which is very complex. It requires, you know, very good engineers. And it's about the complexity of the code rather than other bits and pieces like the infrastructure or APIs on top of it, and they don't know how to tackle it. On the other hand, you know, while speaking about the reality of it, the things are looking differently. So Vlad, maybe if you can. And if you want to bring more clarity to the picture, what happens actually in reality?
Yeah, actually in reality, you know, since we're talking about machine learning, so basically models that learn from data, the most important thing that organizations need to do is actually to collect the data, right? So to have a way through which they can analyze this data, they can verify the data. And then the next step that they can have on top of that would be, you know, to try to seek out a way in which they can govern this data. They can see how to access all this data so that they can later use it. So then on top of that, then we can start thinking about bringing AI into the picture. And it can be as simple as consuming existing off-the-shelf APIs or existing libraries. But at the same time, when we introduce this, of course, we also need to introduce a means of evaluation of these existing systems. But then, if you know the simplicity in this in this condition does not fulfill the requirements of the specific verticals the customers are in, then we can speak about further adding, you know, specific or custom machine learning into the picture. But together with it, organizations need to prepare for more complex things, like, for example, they need to ensure that they have a data labeling pipeline so that they can pre-process all this data that they feed into the models. And on top of that, they need to think in terms of serving this model, so basically establishing the infrastructure for it. And then last but not least, observing what happens to the model and the data in production. Mm-hmm. Yeah. So if we come to kind of sum this all up in a pipeline, then, you know, the typical life cycle of a project and what goes into it, in a way, it's very similar to software engineering. But at the same time, there are very important differences. As we can see, when we're talking about both ML and software engineering, we're talking about scoping and deployment. However, something very important happens in between. So basically, we're talking about the data stage, the data and the modeling stages. Now, this is the main problem when it comes to productionizing AI. Many organizations, as we've seen in the initial slide, they focus on the modeling part and they waste a lot of time and effort into coming with something super advanced rather than focusing on deployment first and then reiterating through these stages. And this is why also many organizations ask themselves, where is my return on investment? Well, deploy it first and then try to experiment it, see what the problem is, and reiterate over this process as soon as possible.
And if it is to put it more, practical, how would you see, like a real world case study?
Yeah, that's a good question. It's the thing that I thought about, and one case study that we prepared actually is the entity resolution, the task of entity resolution over time. So basically, what entity resolution means is that when we have, let's say, 2 data points, the resolution is actually the process via which we say whether these 2 data points point to the same entity or they point to separate conceptual entities. So this scenario can be encountered in various verticals. So basically, we're thinking about product comparison systems, where you have multiple data sources, multiple merchant stores, and then the products get compared. You get banking, we get regulatory technology or government data. Now, the scenario was the following. We had multiple data sources, and these data sources were in a continuous evolution. The data collection process was also continuously evolving. And at a certain point in time, a team was tasked to create such an entity resolution model. So that model was deployed in production. And then it started bringing results to this data. So basically, let's say that data point 2 and 3, they pointed to the same entity, the same conceptual entity, so they ended up in the same place, whereas data point 1 ended up in a different entity. Now, the problem was that the performance of this model degraded over time. Why? And nobody knew what exactly happened. Why did this happen? On one hand, because the data that this model was trained on, it was not necessarily the real sort of view of the data in production. And on the other hand, once the model was deployed, there was no actual feedback. So basically, even while the data collection processes and data formats were changed, the model was not updated. And this is why the product team got all sorts of complaints directly from the customers. And so this is an example where all these parts like data processing, modeling, and post-factum observability are super important in machine learning.
All right, but this is kind of advanced, right? So,
yeah.
So if it is to go and stick a bit to the affordability of it,
yeah.
I think it's also about the level of maturity that your products are at. So if it is to make a good parallel between another webinar that we've held, Remus is having a really nice classification on the certain systems and the level of maturity that your product is right now. And usually it's also related to the power and to the stickiness and to the added value that this can be delivered to your customers. And if it is to start from the basics, at the bottom of the things, we're having products that started to digitalize information, basically replaced pen and paper, started to track information down, store it into databases, and yeah, pretty much this is it. And this is what we're calling systems of a record. It can be a simple CRM on an ERP, which comprise most of the companies in CSI, but also a lot of the ISVs that we're working with. Now, as the things evolve, the next level, which offer more stickiness, it was also offering more engagement towards the user. So we're calling them systems of engagement, and you can think about having also as add-ons into your product conversational and interfaces like mobile experience and web, which offered a higher degree of engagement to the users and also a greater stickiness towards your products. And the highest level that you can be right now with your product, it can be into what we're calling the systems of intelligence, which besides good conversational interfaces, offer stickiness through the power of a reasoning that is being offered to the users. And this can go, and it can be through machine learning or business intelligence or offering enough analytics and so on and so forth. And we've been talking about certain and applicable use cases of narrow AI and of machine learning. And we also think that in order to give some advices, it's very important to understand the step that you are in. And what we've been trying to offer is like a framework to actually realize the situation in which you are right now, and how can you go to the next steps so that you can offer more value to the customers and also more stickiness to the users. And if it is to look at it from a different perspective, basically we've uncovered like 4 levels that you can be in right now. So the level 0, which means no AI, means that probably you have a system of record, meaning that you do certain digitalization, you're offering systems to centralize information, also having certain reporting, and pretty much this is it. The second level that you can be in is having some automation in place. So basically, either having some RPA, collecting data from an email, inputting it into your system, or certain alerting mechanism, or offering human predictions based on the data that you already have in, or offering decision augmentation. And just to give you an example, one of our customers into the healthcare vertical, basically, they've been doing reports on the number of calls that their customers were having to their call center and to their customer support. And they've seen, and this was just human predictions, the employees did that. They've seen that whenever the amount of calls is dropping to customer support, after a few months, there is a high probability of losing that customer and having a higher attrition. So they've just created a simple alerting system in which, okay, when the number of customer support calls drops, they will just maybe try to engage back with the customer and try to understand what's the problem there. So this is a very simple automation, not necessarily AI. You can also be into the next level, which is, like a simple AI. So basically you're into a systems of intelligence where you have or you use existing solutions from the market, like from Azure or from AWS or from Google AI, certain services or pre-trained models to do either standard predictions or, I don't know, basic tasks, maybe basic forecasting, grouping the data, or detecting anomalies. And you can do that using a statistical model and not something that evolves over time. So just to give you an example, at some point we've experimented at a hackathon, a task of in the warehousing industry, reading the license plate of a truck and displaying inside of a warehouse like the contents of that load, so that in that case, we would be reducing the time spent by the unloaders inside of the warehouse of knowing what they will find in the truck. So it can be simple systems. And in this situation, like reading the license plate, that's a pretty standard model, pre-trained. It can be found on the internet and so on and so forth. And also, as the title of this webinar is, affordable AI and doing innovation with it, we concluded that in those 3 levels, basically, this is very affordable to do. You can use your existing staff. You don't need to hire, certain higher capabilities to do it. And it's a thing that we would recommend to focus on. On the other hand, there is this more advanced use case, which we're calling evolutionary Ais, in which we're having systems of intelligence where the information is more complex, the extraction maybe that it's needed can be more complex, and also the ML models are not very standard. They cannot be pre-trained. They are dynamic all the time. They need to be retrained. The data needs to be revalidated. So the models are very interconnected and complex. And this is another stage where you can be, where also the way to solve problems with it, it's a bit more complex. So trying to give some advices on what can be the next steps. So for example, if you're at level 0, a good advice to take is to start recording data. Either if it's task data or analytics or usage data, and start to investigate actually based on it, what tasks are, susceptible to automation, and think about, maybe try to do human predictions. So your employees to do predictions of more data rather than just the data which is domain specific that you already have. If you're on level 1 and you already have some automation, maybe it's the moment to prepare and collect data for doing later on statistical modeling. And we recommend quite a lot, as the cost of storing data, it's pretty low and decreases all the time, to either create data lakes or data warehouses and collect as much data as possible. So a strategy of collecting all as later on can be used for applying statistical modeling, pre-trained models, and so on and so forth, and investigate certain use cases and to offer you the possibility to move on. In level 2, if you already have pre-trained models, but you need, and the business case moves you forward, maybe it's time to find use cases that are not giving the optimal results. Maybe in your vertical, you are having, more need of a dynamic model. And I think it's about investigating, how to switch to a more continuous ML process and to have evolutionary models. And if you're into the last level, where you already have continuous model with a lot of data points, and you need to have ML code that needs a continuous improvement, maybe it's time to think about using like a good process like MLOps. And I would like to ask you, Vlad, here, what is this all MLOps about?
Yeah. I'll go super brief on this because I can see that we're running super fast out of time. So basically, in the same manner as DevOps has emerged over time, I would say that MLOps is a set of tools and practices that allow us to reach this goal of having machine learning deployments in production and running them in a very, how do you call it, sustainable manner, right? So they're not just there, but they also bring value. I would just resume to that without going into technical details.
Mm-hmm. And okay, if it is to then give a step back and try to reason about it, so how can we identify, and map the practical use cases to do ML modeling? How would you approach that?
Yeah, I think it stands in sort of the product area, right? If we think about products and we think about the scope triangle, we think about quality, we think about time, and we think about cost, right? So whenever thinking about your specific scenarios, try to think whether there is a specific task that requires reducing costs. So for example, in predictive maintenance, there can be models that help factories to identify the right time when they need to do maintenance for their equipment, so that they can prolong the lifetime of those equipments and thus reducing costs. Furthermore, reducing time. When we're thinking about reducing time, we're thinking about potentially, having systems that help you automatically extract data out of documents. So basically, for example, for receipts, you want to extract data out of receipts and automatically get them entered into your system. That virtually decreases time to zero, right? And then there are various scenarios in which also quality can be increased. So, for example, there are more and more emerging state-of-the-art in, for example, chemical or pharmacy, where they're doing experiments and they want to identify the toxicity of certain compounds. And there are models which trained by multiple or with the aid of multiple subject matter experts, they can reach certain, performance or accuracies that in many aspects or in many situations can, bypass the ones that are encountered in lab tests.
And if it is to add here, I would also put, simple experiences that we had with either things that, ended up into production or things that remain just at the level of experiment. So, for example, in order to reduce quite a lot of time in the finance industry, we kind of make the process of collecting data from ID cards way faster by scanning the ID card and also directly recognizing the text. Also, trying to understand and make faster the reading of certain meters that you might have into the utilities industry, into the parking industries or warehousing by using, I don't know, license plate reading algorithms. We kind of foster innovation in terms of faster decision whether or not it's the right load at the right time. We've also applied that into like oil and gas, for like oil and gas stations where when a car arrived, for example, at the pump, based on the number of based on reading the license plate, to also reason whether or not that car had incidents in the past of not paying or certain things.
So basically identifying the risk, right?
Yeah. Also in terms of reducing the cost, we've been experimenting in production with conversational interfaces like chatbots on the authentication process in a call center, or on trying to get the proper information like from a knowledge-based system. So like in Software X, where it was having quite a high amount of customers that were using it. They've changed the UI, and in order to reduce the time that is spent on calling the customer support or on doing training about the interfaces, whenever they had any questions, they could have done just by putting questions into the chatbot and trying to come up with knowledge-based paragraphs for them. We also did it into the labor market management, using cameras to detect presence and help with the time registration in factories. Last but not least, you can also maybe mention about it.
Basically document understanding, which we've in some form it's very similar to invoice extraction. So basically whenever, and this can apply for any vertical virtually, wherever you have processes that can be or data entry processes, those can already be automated with the use of more complex, let's say, document understanding machine learning models, which are able to extract exactly the data that you're interested in.
And I think there are a lot of use cases. And what I want you to go out with is that AI is not that, it can be that big of a deal, and it can become complex also if your problem is very complex. On the other hand, it has a lot of use cases of reducing costs, reducing time, increasing the quality, that can be easy to apply in your specific case. And first of all, I would be investigating whether or not existing solutions or frameworks or libraries are already there. And there is this question, right, which is on my lip as well, on the lip of every software product company stakeholder, about how late am I to the party? Is it too early to adopt it? Is it too late? Is everybody using it? Where am I? now?
I think making abstractions of the findings that the Gartner team has found, I think it's the right time to join the party, and I'll tell you why. On one hand, as Bogdan also mentioned, there are, I mean, all of the cloud providers, major cloud providers, they're also providing dedicated artificial intelligence APIs that can be readily consumed. So this is one argument why I would say. Another argument is that the open source tools have emerged and have matured so much and have demonstrated the capability to deliver successful projects to production, or using them to deploy successful projects. And as well as, standard processes that have also emerged, and the focus on automating them, I think we can conclude that it's actually a good time to join ship. And as we've discussed so far with Bogdan, I think this can be done gradually. So, if you have any ideas or things in your mind that you would like to discuss, I think Bogdan and I are here to discuss with you about them.
Yeah, and it can be, a personal discussion, or if you have questions right now, don't hesitate to put it into the Q&A part. So I think we're pretty done with the content, and we're waiting for some of your questions if you have any. Oh,
I see no questions yet.
Yeah.
So in the meantime, we also have a poll, right? An exit poll, which if you would be very kind, it would to fill in, it would be really nice for us to see.
Yeah. And also with this occasion, I wanted to thank all of you that you've made the time again for the US participants. I hope you already had the coffee. For the Australian participants, I hope you didn't drink any coffee in the past hour so that you can go to sleep because it's the middle of the night. And for all the European participants, it's quite a good time for and ending the workday. Here I'm hearing in our office there is a good celebration party, so we will be heading there as well.
Thank you.
Yeah. So let's see. Maybe I can refresh the list to see. Open.
All right, we have an incoming question.
Yeah. So the question is, do we have any data on monetization revenues of products using AI?
I think this kind of practice has been actually made available in big companies like, as you mentioned, Google and Microsoft and Amazon. It's actually a practice at huge enterprises where they have I think they provide a public report, an earnings report, where they have especially or specially designated sections where they treat each of their product initiatives. I think it also depends, right, on the type of product that you're building, and it also depends on the
level
scenarios. Exactly.
I also think it's very related to the level. So I've seen some polls from Gartner. So on if you're on the very complex scenario, the return on investment usually it's a matter of years. But if it is to judge it based on the answers that you gave, also if it is to judge based on you know the other initial levels, which we've characterized them as affordable AI, usually it can be that the monetization or the return on investment can be a matter of just months, and it's super affordable. So you can do it with your own staff. And this is why I've insisted on it. So simple AI or automatization, you can do it with your own staff. You can take off-the-shelf products or libraries, and you can use it in production without too big of an investment. Any other questions? Incoming. All right then. Well, to put it differently, we're very. So we're having another one. How affordable is MLOps on on-prem clouds?
All right, so MLOps on on-prem cloud. So basically, when we're thinking about MLOps, again, and I would link it to the answer of the previous question that Bogdan had. It depends on the maturity in which your organization is, because if you're building an MLOps pipeline, you can actually, you know, the simplest way you can deploy that is actually on your local computer. That wouldn't be a problem. The costlier part of the MLOps pipeline would be the resources, the resource hosting that you need for training actually the model, because in many situations you may need graphics enabled machines, and those are more expensive. So basically, you know, if you need to something like that, then you would of course need an infrastructure that has a graphics accelerator in it, right? So, you know, a PC, a CUDA enabled PC on your on-premise environment, I suppose, that you can use, and that's mainly it. So it's a good starting point, and I think that's super affordable, right? Any one of us can.
Yeah, but on the other hand, if it is to give like a business answer to it, so I would say MLOps applies into very complex problems. There is a really nice saying from Elon Musk to use AI only when this is the last option, and you've basically, you know, dismissed all the other automatization, simple AI, and so on. So this is for advanced or very advanced use cases. So I think the biggest expense here is the staff, because most probably AI MLOps, meaning you will have complex pipelines, dynamic model, and also like a very complex environment. You'll need to have proper staff. You'll probably need to have data engineers, and I think there is the biggest expense related to MLOps.
Yeah, I agree with that. That's a spot on. Yeah.
Cool.
All right.
We hope we've answered it.
Yes, and we're a bit over time.
Yeah, and I think we are a bit over time. We will gladly be answering to all of your questions. Don't hesitate to contact me or Vlad, or get it through Monique through our website. and whatnot. And we will be very, very happy to discuss about your case and to also try to, deep dive into your specifics or the specifics of your business and try to come up with, smart and also affordable answers and use cases for your situation. So thanks everybody. And we hope to see each one of you to our next webinar and to see you soon.
Bye.
Bye.